Okay, next page in our notes, just looking at like unwanted voltaic cells. So rusting is an example of an unwanted voltaic cell. If we have iron and oxygen and water, okay, mixed together, we get this voltaic cell, which then produces iron 2 plus, okay, and which is rust. We don't want that because then it wrecks our vehicles and stuff. Okay, and so yeah, many metals are easily oxidized by oxygen. Okay, and so then it causes these voltaic cells to happen. In each small cell, iron acts as the anode, and the cathode is inert, and may be an impurity that exists in the iron or deposited into it. So like if you get soot or dust or anything on your vehicle, and so that's why like you want to make sure your vehicle is clean, or it'll keep like as long as you don't have those impurities, you shouldn't rust as much, and you're going to do different things to protect it. Again, so one way to diagnose for corrosion, okay, is because it's producing this OH ion. Okay, we can put a little bit of phenolphthalein near it. If it turns pink, you know it's starting to corrode and starting to turn into rust. Okay, um, the color will get darker if the iron corrodes, and so that's like if we're checking here, that's what we might see. Okay, there's different ways we can kind of prevent rust or corrosion. So if you paint an object, okay, basically you're adding a protective layer. Okay, and so water and impurities can't reach that surface, and so then the voltaic cell doesn't work, or like the reaction won't occur. Okay, you can coat it with a different metal that's more resistant to the corrosion than iron. So like if you put a layer of chromium on bumpers, okay, metal trim on cars, it then it'll, as long as it completely covers all the iron, okay, then it should work and protect that iron. The one problem is like you get any holes or scratches in that layer, that's when it'll start to rust. Okay. You can also form an alloy with a different metal. So like stainless steel is iron that contains at least 10% chromium. So then again, it changes its kind of uh, reduction potential or oxidation potential. Okay, galvanizing. So this is when iron's covered with zinc. Okay, so nails, metal buckets, chain link fences, all of this kind of is um, examples of galvanizing where it's protected with this layer of zinc. Okay, so the zinc acts as a protective layer. Zinc is more easily oxidized. Okay, and so like if we look at our table, zinc's below iron. So zinc becomes the anode of the cell instead of iron. Okay, and when iron reacts, acts as the cathode when zinc is present, making it almost like it produces more iron. Okay, this iron metal is oxidized to, or the zinc metal is oxidized to zinc ions. Okay, another word for this is a sacrificial anode. This becomes the anode, which then gets destroyed instead of like the metal, like iron that we want to protect. Again, and the last one is cathodic protection. So a more reactive metal is attached to iron, uh, to the iron object, and this reactive metal acts as a sacrificial anode. So that's where like on pipelines and stuff, if you have a metal pipeline or iron pipeline, just every now and then you have to add just a piece of a more reactive metal that works as a sacrificial anode. Unlike galvanizing, the metal used in the cathodic protection does not completely cover the iron, it's just attached. And so then this again becomes the anode, it's solely destroyed. Okay, and so like then you have to replace it kind of periodically just to make sure that it still is working as that anode. So that's what they use like on a lot of pipelines, things like that. So you can, it doesn't have to actually be part of the pipe. It just has to attach somewhere on the pipe, and it becomes that um, sacrificial anode.